class we will focus on the activity-based costing system, which is another approach that can be adopted in order to assign the overheads to the final cost object. The main characteristic of an ABC approach is that overheads are assigned to activities first and then they are allocated again to the final cost object. Let's try to compare a traditional costing system with an ABC approach in order to understand the main differences, because in both of the cases we are allocating the overheads. If we have a traditional costing system, such as the job order costing, which is a typical example of a traditional costing system, the approach is the following. We have the overhead, so the value of our indirect resource, and we assign the value of our overhead to the final cost object by calculating an allocation coefficient K. If we have instead an activity-based costing system, still the starting point is represented by our overhead. So we have the indirect resource, but the indirect resource, rather than being assigned directly to the cost object, it is assigned to the activities first. So the value of the resources is assigned to activities. Activities for which our resource is used. For example, if we have a machine, we try to identify which are the activities for which we are using a machine. If we have a supervisor, we try to understand which are the activities that are carried out by the supervisor. How can we assign the value of the overheads to the activity? By using an allocation approach, by using an allocation coefficient. So still, we calculate K. Then, once we have the cost of the different activities, we will assign the value of our activity to the final cost object. How can we do this? Again, by using an allocation methodology. So we will calculate K another time in order to assign the value of the activities to the cost object. So you can see that what changes between these two different approaches is that in an ABC approach we are allocating costs twice. First, we are allocating the value of the overheads to the activities, and then we are allocating the values of the activities to the final cost object. In order not to make confusion between the two different K, this K is defined as resource driver, and the reason why is because this K is used for assigning the value of the overheads, which are indirect resources, to the activities. So we can also call this K as K of the resource driver. While in this case, we are assigning the value of the activities to the cost object. So this driver is defined as activity driver. They have a different name, but so in this case we can also define this K as K of the activity driver. They have different names, but the approach is exactly the same that we use for a traditional costing system. What's the main difference between a traditional costing system and an ABC approach? If we use an ABC approach, of course, we are increasing the complexity of our system because we need more information, we need more time, and it is more expensive applying this approach. But we are increasing the precision because we are identifying the activities that absorb the resources, and then we identify the final activity driver. This is more precise because of the introduction of the activities. Usually, the resource driver is represented by the time. If we have a resource, we look for the time for which the resource is employed for performing different activities. Once we have the cost of the activities, we can have several different types of drivers. Let's see with an example how this ABC approach works. We will see that we are not introducing any new formulas, but we are just applying this allocation twice. Assuming that we have this problem. We have our indirect resource, which is our machine. So we have the machine depreciation, whose value is 90 euros, and we want to assign the value of our depreciation of the machine to two different products which are realized, that are our two different cost objects. We have chairs and we have tables. The data that we have for a period that we are analyzing are the following. We are producing 12 units of chairs and 2 units of table. This is the production time. We need 10 minutes in order to realize one chair, and we need 30 minutes in order to realize 1 unit of our table. This means that the total production time, if we multiply the quantity by the unitary time, is 120 minutes for the chairs and 60 minutes for the table. So overall, we need 180 minutes for the production. But we have also additional information because our machine is not used only for production, but for some time the machine is used because of the setup. We do not have, it is not available, the data about the time for the setup for each of the two different products, but we know the total time of the setup of both of the products, which is 20 minutes. And we know that there is one setup before starting the production of the chairs and one setup before starting the production of the table. So we have a total of 2 setups. It is required to assign the value of this machine depreciation to the two different products by using an ABC approach. What we need to do as a first step, after having identified the value of our resource that we want to assign, is to identify the activities for which our machine is used. Which are the activities for which our machine is used? If we look at the data that we have, we can see that our machine is used both for producing but also for the setup. So the two different activities that we can identify are the production and the setup. How we can define the cost of these two different activities? By calculating our K, that will be the K of our machine depreciation. This K will be equal to the total overhead divided by the total allocation basis, a traditional allocation. What's the total overhead? The total overhead that we want to assign is 90 euros. These 90 euros should be divided by the total allocation basis. Which is the total allocation basis? The relationship that links the machine depreciation with the activities is the time required for producing and the time required for setup. So we will have that the allocation basis for the production is the time for production. So this allocation basis will be 180 minutes. 180 minutes is the time for producing, plus the allocation basis of the setup. And the allocation basis of the setup will be 20 minutes. So overall, the machine is used for 200 minutes. And we will have that K, so the allocation coefficient will be 0.45 euros per each minute of usage of the machine. So this is 0.45, which is the allocation coefficient. Now, if we want to calculate the cost of the two different activities, so the overhead, which is assigned to our production, we need to multiply our K, which is exactly the following, the K of the machine depreciation, by the allocation basis of the production. And the allocation basis of the production is exactly 180 minutes. So if we calculate this, we will have 0.45 euros per minute, which is K, that should be multiplied by 180 minutes. And we will have that the cost of the activity production will be 81 euros. If we do the same with the setup, I do not repeat the calculations because they are the same, we just multiply the 0.45 euro by the allocation basis of the setup, which is 20 minutes. So we will have that the cost of the setup is 9 euros. So in this case, we are just sharing the value of the machine depreciation between the two different activities on the basis of a resource driver, which is the time for the production and the time of the setup. Once we are at this level, we need to repeat this approach another time because we need to share the value of the two different activities between the two different products. So our cost objects are chairs, and then we have tables. So we need to calculate an allocation coefficient for the production and an allocation coefficient for the setup. Let's start by calculating the allocation coefficient of the production. So K of the production, this one, will be the total cost of production, that we can call the production cost, divided by, again, an allocation basis total related to the two different products. We have that the total cost of production is 81 euros divided by the total allocation basis, so which is the relationship between the activity of the production and the two different products, the chairs and the table. Again, we can see that the time for producing chairs is 120 minutes and the time for producing tables is 60 minutes. So we can divide these 81 euros by 120, which is the allocation basis of the chairs, plus 60, which is the allocation basis of the tables, so that we will obtain 0.45 euros per minute. In this case, we have found the same allocation coefficient, but the reason why is because we are using the time as an allocation coefficient for both of the cases. Once we have this k, which is the k of the production, we need to assign the value of the production, this 0.45, between the two different products, the chairs and the table. So if we multiply 0.45 by 120, we can find the cost of the production which is assigned to the chairs, which is 54 euros. Then, if we multiply this 0.45 euro per minute by the allocation basis of our tables, we will obtain, as a cost of the production assigned to the table, a value of 27 euros. And we need to repeat this approach for all of the activities. Now, if we move to the activity of the setup, we need again to identify an activity driver, which is that quantity that explains the relationship between the setup and then the realization of the chairs and the table. If we look at the data that we have, unfortunately, it is not available the data about the time for the setup for the chairs and the time of setup of the tables. For this reason, we cannot use the setup time in order to share the value of the activity of the setup between the two different products. But we have just the quantity as a data which is available for both of the products. So if we calculate K for the setup activity, we will have the cost of the setup activity that will be divided by the total allocation basis. So we will have 9 euros that will be divided by the total allocation basis. In this case, the total number of setup, so 2 setups. We will have that each setup costs 4.5 euros. Again, given this value, which is our allocation coefficient, this 4.5 euros per setup should be assigned to the two different products, chairs and tables. We can see that we have one setup for the chairs and one setup for the table, so it is just this value split between the two. So we will have that the cost of the setup for the chairs will be 4.5 euros and the cost of the setup for the tables will be again 4.5 euros. How can we define the total value of our production? Simply by summing the cost of the activities that has been split into all of the products. So if we sum this value, we will obtain 58.5 euros as a total cost of the chairs and 31.3 euros as a total cost of the tables. If we look at the structure, at the schema of the exercise, we can sum up the steps in order to apply an EBC approach. The first step is to identify the overheads. Once we have identified the overhead, so the resource that we want to assign, the second step is to identify the activities for which our resource is used. Then we need to allocate, by using a resource driver that is usually represented by the time, the value of this resource between the different activities. Once we have the cost of the activity, we need to split the cost of the activities among the different products by using an activity driver. If we sum up all of the costs that we have, we can identify the total cost of the final cost object by using this approach. It is of course time consuming with respect to a traditional costing system, so usually the ABC is suggested only in the moment in which the incidence of the overhead, so of the indirect cost within an organization, is really high. Otherwise, it is much more convenient to use a traditional approach.